The compact PE1437 pulsed eddy current flaw detector is designed to detect corrosion in steel objects with insulation thickness up to 100 millimeters. During an inspection, the device magnetizes the surface and then measures the demagnetization process. As a result, the flaw detector can estimate the amount of steel located under the sensor with high accuracy. Since the device does not measure the thickness of the object directly, it requires a reference point for operation, so it is necessary to calibrate it on the object where the metal thickness is known. For calibration, you should only enter the thicknesses of the object and the insulation at the calibration point. After that, measurements can be taken. The device displays a demagnetization graph, which is abbreviated as an A-scan. The reference curve obtained during calibration is displayed in red. The curve of the current measurement is displayed in yellow. If the yellow curve noticeably shifts to the left relative to the red one, it means that there is significantly less metal under the sensor, or a defect is detected. As we can see, steel discs with a thickness of 10, 8, and 5 millimeters are measured with high accuracy through a 50 millimeters thick insulation layer. It is important to note that calibration should be repeated for each new object. The flaw detector can be connected to two sensor types. The small sensor operates through insulation up to 30 millimeters thick and detects corrosion spots from 20 millimeters in diameter. The big sensor operates through insulation up to 100 millimeters thick and detects corrosion spots from 40 millimeters in diameter. The sensor can be easily replaced. However, after replacement, you need to specify which sensor is connected to the device and to carry out a simple sensor calibration in the air. Let's measure a real pipe with insulation. The thickness of the pipe and insulation at the calibration point can be checked in the data sheet for the test object. You can also measure the thickness at the calibration point using, for example, an EMA thickness gauge. In this case, you may have to partly remove the insulation at this point to provide access for the thickness gauge. In spite of the fact that the pipe looks the same externally, there is a step from 12 to 4 millimeters in thickness inside. To visualize the measured area, we switch to the C-scan display mode. The C-scan is a surface map. To get it, we should set its dimensions, the base, and minimum wall thicknesses. Please note that the measurements with the pulsed eddy current flaw detector require a similar insulation thickness in the inspection area, with deviation of no more than 10% from the calibration point. In the area where the insulation thickness differs significantly, a new calibration is required. In addition, to eliminate interfering magnetic effects, the measurements must be taken maintaining the sensor direction relative to the pipe. We see a step transition of wall thickness from 12 millimeters to 4 millimeters on the C-scan, which corresponds to reality.